So okay, so we're going to talk about velocities now. Okay, so let's talk about velocities. Okay. All right. So let's start with the simplest case. Okay, so this is something that you probably learned in dynamics. Okay, probably like the first few weeks. Okay, so there you had a fixed frame. Okay, and let's say you had a particle, some particle moving in space. Say here. Okay, so let's call this vector, say p, and it's moving, so it's a function of t. Okay, and you want to be able to write not only its position, but also say something about its velocity and its acceleration. Okay, all right. To make things a little bit interesting, what do they have? You usually have another frame. Oops. Let's put the frame, okay, that way, say. Okay, so you have two frames. Okay, so this frame is fixed. This frame is moving. All right, so let's call this fixed frame large x, large y, and here's large z. Okay, and to make this example a little bit more real. Okay, so here is, okay, so, all right, it's a missile. All right, and here is, all right, so here's Seoul. Okay. And so I want to turn this into a sea of fire. Okay, so if I want to have a sea of fire, so here's the Taepodong. Okay. Now, they're not very good at, it's not very accurate. Okay, so not clear where it's going to land. Okay, hopefully not Seoul. Okay. So we have all these satellites and airplanes. Okay, we have, I don't remember the name, but we have all these great airplanes provided by the US Air Force. Okay. Okay, so they have all these like special radar, and they track it. They track this missile. Okay. So rather than measure this directly, it's in fact easier for this plane to measure the position of the missile. Okay. And then this airplane sends information to the ground station. Okay, so here's the ground station. Okay, so here's the ground station. Okay, so we know this. So we know that. Okay, all right, so we want P of t. So let's call this P sub A. Okay, and this vector let's call P sub M given A. Okay, and in fact, let's say this is P sub M. Position of the missile. Okay. Position of the airplane. Okay. So we want PM sub T. And this can be expressed as P sub A plus P M sub A, also function of time. Okay. All right, so P sub A we know. This can be expressed as large X of t, large X hat plus large Y of t, large Y hat plus large Z of t. Oops, Z of t, Z hat. Okay, so that's P sub A. And then P of M given A plus, let's use small letters. So small x of t, x hat plus small y of t, y hat plus small z of t, z hat. All right, so this is my P of M given A, and this top term is P of A. Okay. All right, so that means I'm labeling these frames, the axes of the moving frame, as small x, small y, small z. Okay, so here's small x, small y, and small z. Okay. Okay, so it's nice to know the position, but it would be nice to also know the velocity and the acceleration, okay, to see how much time we have before our, right, we turn into a sea of fire. That's okay, so how do we get the velocity? Okay, so V sub m is just what? The derivative of P sub m. Okay, so we take the derivative of this to get the velocity. Okay, so that's easy to do. Okay, so it's x dot, let me just get rid of the t's, x hat plus y dot y hat plus z dot z hat. Okay, and then plus, now when you take the derivative of, let's go here, when you take the derivative of this term, what is it? It's derivative of this times this plus this times the derivative of this. All right, so in this case, it's pretty obvious what it's going to be, but let's just write it. Okay, so indulge me. Okay, and we know that these large x, large y, large z, okay, if we take the derivative, it's going to be 0. Why? Because it's a fixed frame, right? It's not moving. So these terms are all 0. Okay, 0, all 0. Okay, now we still have one more term. Okay, so let's do that. Small x dot x hat plus small y dot small y hat plus small z dot small z hat. Oh, we also have, right, plus x times x hat dot plus y, y hat dot plus z, z hat dot. Okay, these are not necessarily 0. Okay, now if the plane is flying, okay, in a fashion such that the orientation is always the same, it's always same orientation, then these are 0. Okay, but if the plane is changing orientation, okay, not 0. Okay, these are not 0. Okay, so now the question is, what are these? Okay, this is what we need to answer. Okay, so let's do that now. So obviously it depends on the orientation of this frame, right? Okay, so now let me draw the frame. Okay, so here's x at t, here's y at t, and z at t, small x, small y, small z. Okay, and let's say that at a short time later, say delta t seconds later, the orientation changes. Okay, so here's the airplane, it changed orientation, so it's maybe banking like this. So these are going to pointing in a different direction. So this will be x hat t plus delta t. This will be y hat t plus delta t. And finally, we have z hat t plus delta t. Okay. All right. So if I asked you, I want to express this rotation from xt, yt, zt to this red frame, okay, as maybe some rotation. Okay, so how would you do it? How would you do it? Well, you know that we can express this rotation as a rotation around some axis. Okay? So we can find this some axis. Okay? And we rotate this white frame around this yellow axis by some angle. Okay, let's call it delta theta. Okay. So what we're saying here is that x hat at t plus delta t, y hat t plus delta t, z hat t plus delta t, okay, can be obtained as a rotation of the x, y, z frame about this axis omega hat by an angle theta. Okay, is rotation about this axis omega hat by an angle theta of the earlier frame, right? X hat, y hat, z hat. Okay. Okay. So if I asked you, give me an explicit formula for this. Okay. Would you be able to do it? Yes, you should be able to, right? Because this is the exponential, right? So if I give you values for these three vectors and these three vectors, okay, then you could get this for me, right? Use the log formula. Bring this over to the other side. Write this as an exponential of some omega hat times theta, okay? And then use the log to get omega hat and theta. Okay, all right, so this is the situation that we're in right now. Okay, so now let's imagine the following. So suppose now this interval of time delta t gets really small, infinitesimally small. Okay. Suppose it gets really, really small, close to 0. And let's think about what happens to omega hat and delta theta. Okay? So omega hat is not going to go away. Okay, it's not going to go away. It's going to go to something. Right? It's going to go to something. Okay? So what is that? Omega hat all right, so before we do that, let's so let's say omega is omega hat times theta. Okay? So let's think about what happens to omega as delta t becomes arbitrarily small. Okay. So omega is going to go to some vector. Okay. What is that vector? That vector is the angular velocity vector. Okay. Is the instantaneous angular velocity. Okay, as delta t becomes very small. And delta theta over delta t, okay, this in the limit goes to what? The rate of rotation. Okay, this goes to theta dot. Okay, it's the rate of rotation. Okay, so anytime an object, a frame is changing orientation, okay, in a continuous way, you can associate it with this angular velocity vector. Okay, so think of that picture. All right. Now the question we wanted to answer, okay, question we really wanted to answer is, right, this is what we want. Okay, but now we know that something like this exists. Okay, it's physically plausible. Okay, what the instantaneous angular velocity vector means. Okay, so let's think about this. So suppose we have, all right, so here's my vector omega. And let me draw my vector x. X hat at t. Okay, so this frame is rotating about this axis instantaneously. Okay, so that means this vector is rotating about this axis instantaneously. Okay, so it's going to be tracing a circular path. Okay. So I want to know, what is the velocity of this point at the instant shown? So what's the velocity of this point? Okay, so if you think about it, this is tracing a circular path. Okay, assuming this doesn't change orientation. Okay, so the velocity always points tangent to the path. It's always tangent. Okay, so it's going to be x hat dot is pointing this way. Okay. All right, and now if you look at this picture long enough and think about it, you'll be able to convince yourself, okay, just from basic trigonometry, that in fact omega hat dot, or sorry, x hat dot is in fact just omega cross x hat. Okay. So let's put an arrow over this. Okay, put an arrow over this omega. Also, arrow over here, and arrow over here. Okay. Okay. So x hat dot is just simply omega cross x. Okay, so if you think about it, use the right-hand rule for cross products. Okay, you can verify the direction is correct, and the length is also correct, right? It's the length of omega times the length of x, which is 1, times the sine of the angle between omega and x. Okay, so this is true, and in fact, so is and this. Okay. All right, so if you know the instantaneous angular velocity of a frame, then you always know the velocity of the unit axes x, y, and z. Very simple. X dot is omega cross x, y dot is omega cross y, z dot equals omega cross z. Okay. Okay. So this is another one of those thumb formulas. Okay. So draw a little thumb here. All right. Okay. Okay. This is going to be a good friend of ours. Okay. And in fact, I don't have time to do this today, but next time I'll show you. What was the hardest part of dynamics? What was the hardest part of dynamics? Okay. It was calculating velocities and accelerations. You remember that? You had formulas like, okay, you had formulas like, right, V sub p is equal to omega cross omega cross r, right, plus r dot, and then you had OXYZ. Okay, remember these things? And then if you had acceleration, okay, this got really crazy, right? You had things like R2 dot OXYZ plus omega cross R dot OXYZ. Maybe there's a 2 here. I don't remember. Okay. Strange formula. Plus omega cross, right? R plus all this other stuff. Right? So I don't know about you, but when you first learn this material, usually what do? You spend a lot of time memorizing this formula, okay? And then on a quiz, right, try to figure out what each of these things mean, put it all together, get your answer, and then 2 days after the quiz, you forget. Right? And probably you'll forget for the rest of your life. Okay. All right. This is a terrible, terrible way to do this. Okay. Okay. This is just taught wrong. So if you have a dynamics book and you see these formulas like that, my advice is just rip it out, throw it away. Okay. Just remember this, and I guarantee you, you don't need this. You can calculate accelerations, velocities, anything. Okay. So I'll show you that next time. Okay. Let's stop here.